we're going to be going over 5.1, which is angles in degree measure. And it's my first screencast, like real screencast with a lesson. So if I started through it a little bit, just bear with me. A real lesson has, a couple of ums and, stutters here and there. And I don't want to have to remake a video 5 times for it to be spotless, right? So let's just dive into it because I don't want this video to take up too much time. So I have a think/warm up here, and it says, can you remember where quadrant 1, 2, 3, and 4 are on a Cartesian plane? And you might be thinking, what is a Cartesian plane? That's just some what is called in math, and that's just your x and y axis. The x and y axis. And then if you remember, quadrant 1 is right there where we usually like to work, where both things are positive. And then we just go around like that. That's quadrant 2, that's quadrant 3, and that's quadrant 4. And that'll just be a little helpful later on. So this is just some math terminology. I'm going to move me down in the corner real quick so you guys have a little bit more room to see what's going on. Okay, it says an angle may be generated by rotating one of 2 rays that share a fixed endpoint known as the vertex. One of the rays is fixed to form the initial side of the angle, and the second ray rotates to form the terminal side. And I like to include like the mathy definitions of things first, so that you can get that vocabulary in your head, and then I like to simplify it. So all that's saying is what an angle is. And you guys know what an angle is, right? But it's just defining some things. So if we were to start on this right ray, and then we move another ray just over that way, this would be the initial side. Because that's the side we started on. And then this would be the terminal side. And then the point where they are fixed is called the vertex. And then usually we give angles names, and a very popular name to get it is the Greek letter alpha, and it kind of looks like a weird A/fish. That's how I write alpha. Now, if the rotation is counterclockwise, then the angle formed is positive. But if the rotation is clockwise, then the angle formed is negative. Now I have a little trick there, and I'll explain what I mean in a second. So if this was our initial side, this first one up here, and then we rotated it out counterclockwise, right? That's counterclockwise. This angle would be positive. And vice versa, if we went the other way, if we rotated clockwise, how a clock goes, that angle would be negative, right? And my trick there is to think of your quadrants, right? So in our X and Y plane, I'm thinking if you start in quadrant 1, the correct order goes 2, 3, 4. So in the correct order, you are going counterclockwise, and the correct order is positive. That just kind of makes sense to me. And if you're going the wrong order, you're negative, and that's what makes sense to me. All right, an angle with its vertex at the origin and its initial side along the positive x-axis is said to be in standard position. So standard position, we'll see in each of these, all their initial sides are just on the x-axis, and their vertex is all right at the origin. And then, as you can see here, this is positive 120 degrees because we rotated counterclockwise, and this is negative 120 because we rotated counterclockwise, and this one is positive 90 because we rotate it counterclockwise again. So, and then in each of these, it just tells you what quadrant it's in. It's good to get used to thinking about quadrants. That one's obviously right on the line, so there's a different name for that type that we will get to later. And that's just going to be important for some problems later on because they just ask you what quadrants stuff is in. All right, the most common unit used to measure an angle is the degree. A degree can be divided into 60 equal parts called minutes, and a minute can be divided into 60 equal parts called seconds. So it's kind of like hours, minutes, and seconds, except we're not talking time, we're talking degrees, minutes, and seconds, which is different, but it's split up the same way. So if you ever have trouble like thinking about how to convert things, just pretend degrees are hours and then change it at the end. And so what this means 1 degree is 60 minutes, 1 minute is 60 seconds, and 1 second is 1/60th of a minute, and 1 minute is 1/60th of a degree. And so a common real world use of angles is for us to plot every single point on Earth via latitude and longitude lines. And that's good for navigation, so we can tell people where to go. Learn how to get there. And then essentially it just works on angles from the equator and from the line formed going through the two poles. So our example 1 says change north latitude 15.735 to degrees, minutes, and seconds. Well, you would say that's the same thing as 15 degrees, which is already in degrees, right? But then the problem is that 0.735, right? So we're going to say that's the same as plus 0.735 degrees. But now, how would I change degrees to minutes? Because that's what we have to do to this 0.735. Now, if I asked you how many minutes is 15 degrees, it becomes a little more obvious, right? You would just times it by 60 since 1 degree is 60 minutes. So we're just going to do that to this 0.735. We are going to times it by 60. And that's going to turn into minutes. And just a little apostrophe is the notation for minutes. So that's going to be 15 degrees plus, and then 0.735 times 60 is 44.1. That's minutes. And again, we run into the same issue, right? We don't want that 0.1 there, so we have to change that to seconds. So the same is 15 degrees plus 44 minutes plus, and now we want to change 0.1 to seconds, so we do it in a similar way, but we multiply it by 60 since it's currently in minutes. And once we do that, you get 15 degrees plus 44 minutes. And you shouldn't need a calculator for this one. 0.1, you just move the decimal over, plus 6, and then seconds is the two little dashes there. And so your answer you can just write as 15 degrees, 44 minutes, and 6 seconds. And now likewise, going the other way, right north latitude 39 degrees, 5 minutes, 34 seconds as a decimal rounded to the nearest thousandth. So this is where thinking backwards comes into play. We already have 39 degrees, right? That's already in degrees, we don't have to change that. But now, how do we change 5 minutes to degrees? Well, remember, each minute is 1/60th of a degree. So we should multiply it by 1/60th. And then now we also have to do that for seconds, right? But now seconds, if we times it by 1/60th, that gets us to minutes. And then for minutes, we would need to times by 1/60th again in order to get to degrees, right? And 1/60th times 1/60th, we can write that simply as 1/3600. And if you calculate that out, you just multiply these first and then add them all together. You should get 39.093. 0.093 degrees. And that's after rounding up. And so that'll wrap it up for the first part of this section.